Hello everyone, today's topic, volume of spheres, and we're going to throw in some extra stuff just as a bonus. Essential questions. How can we find the volume of a sphere? How can we compare volumes? And how can we find the volume of multiple figures together? Let's get to it. First off, here is our volume of a sphere formula. The volume is 4/3 pi r cubed, where r is the radius. Notice this r is being cubed, which means we have to do r times r times r 3 times, multiplying by the radius. Our steps to find the volume, hopefully these are familiar by now. First, identify the radius of the sphere. Second, substitute in the radius into the formula. And third, calculate. Let's do a couple examples. Here we have a sphere. We can find the radius right there. It looks like the radius is 3. Plugging that in, we get volume equals 4/3 pi times the radius cubed. When we calculate that, we do 4/3 times pi times 3 times 3 times 3. That's the radius 3 times. And if we calculate that, we'll get an answer of 36 pi, leaving pi in our answer. Example 2. This time it looks like we have a diameter of 12. What does that mean the radius is? The radius is going to be half of that, which is 6. So we have 4/3 pi, plug in the radius for our r, our radius cubed. That's 4/3 pi, 6 times 6 times 6. And if we calculate that, we're going to get an answer of 288 pi. All right, your turn. Try this example down here, but this time, instead of leaving pi in your answer, use 3.14 and round to the nearest hundredth if necessary. All right, identify the radius and try to find the volume now. Okay, let's see how you did. First off, the radius right there is 7. And if we plug that into our formula, we just switch out the r for 7, 4/3 pi, 3.14 this time, times 7 cubed. That 7 cubed means we're going to multiply by 7 3 times, 7 times 7 times 7. And if we do that correctly, we'll have about 1,436.03. That is our volume. All right, flip your page over. For this next section, we're going to reference back to all 3 of our volume formulas. We have cylinder, cone, and sphere. And here's an example where we compare volumes one to another. Here's the question. How much more water could the sphere hold than the cylinder? So we have a sphere and a cylinder. It says use pi equals 3.14 and round to the nearest tenth. So if we want to compare these, the first thing we need to do is find the volume of both of these figures. If we do that with the sphere, we'll identify the radius of 8 and then use the sphere formula, 4/3 pi r cubed, to calculate that out. That's 8 times 8 times 8. Multiply everything out. We get about 2,143.6 inches cubed. For the cylinder, we need to identify the radius and the height. The radius is going to be half of the diameter of 5, and it looks like our height is 11. Putting those into our cylinder formula, pi r squared h, 5 for the r, 11 for the h. And if we multiply all that out, we'll get about 863.5 inches. So now, since we want to find out how much more this cylinder holds than, the sphere holds than the cylinder, we can subtract these volumes to find the difference. Give that a shot. How much more do you think the sphere can hold than the cylinder? All right, if you did that correctly, you should have done 2,143.6, subtract 863.5, and that should give you an answer of about 1,280.1 inches cubed. So our answer, the sphere can hold 1,280.1 cubic inches more water than the cylinder. Whenever you compare, you have to find both volumes, and then you could subtract to find the difference. All right, last section here. What happens when we have multiple shapes that kind of combine to form an interesting shape? Let's take a look. A hemisphere, that's half a sphere, is placed on a cone. We can see that situation down here. The cone has a height of 6, and the cone and the sphere Both have a radius of 3. What is the volume of the figure? So we have our cone with a hemisphere, half a sphere on top. First, we want to find the volume of each part of the figure. Let's start with the hemisphere. So we're going to use half of the sphere formula. That's 1/2 times the sphere formula, 4/3 pi r cubed, putting in the radius of 3 for our formula. If we calculate that out, we'll get 18 pi. Next, you want to find the volume of this cone with a height of 6. We also know the radius is 3. We put those into 1/3 pi r squared h, the formula for a cone, and calculating that out, we coincidentally also get 18 pi. So that worked out. So now that we know the volume of each piece, we can add them together to answer our final question. What is the total volume? So if we do that, we'll take our volume, 18 pi plus 18 pi, that's our hemisphere and our cone. And then if we do 18 pi plus 18 pi, those are like terms, we can combine those. 18 plus 18 is 36 pi. And there we've got our total volume. All right, take a few minutes to complete your summary. Make sure you're answering the essential questions on top. I hope this video was helpful.